Hi, in this clip video, we talked about standard template library, which is a C++ standard library for many things, including containers, which are data structures that you can keep items and other algorithms primitives. Okay, so today we're gonna give you a quick review of pointers. This is important because many of the idioms and how STL is implemented sort of like mirror how you work with pointers. So you have, if you kind of like have some idea what pointers are and how it is used to iterate over items in arrays. When you use iterators in C++, this one, you look you feel familiar with it. Okay, so let's go see it. Okay, so this is C++ code. One thing that I would like to note is that here I write int star p1. You typically see people like int star p1. You keep the star with the p. Okay, so this is how people do in C, but in C++ we usually group the star here with the type int to indicate that it's a type. Okay, but the way you write this kind of like uh, it's not good when you would like to define many pointers variables, but if you have, because if you want to have many pointer variables, usually like this, right? But yeah, but you cannot put the star to the int here and do it with many pointers variables. Okay, so this is a quick review. Okay, so this is how I'm gonna write, because in C++ we would like to emphasize that this is a type star of int. Okay, so quick review. Star of int like this means that variable p is a pointer to a type int. Okay, what does that mean? Okay, so let's try to make it concrete. So you have let's start with these two lines. So you have variable x, okay, that keeps the number 10, right? And you have another variable a, which is a double that keeps the value like this. P1 is a pointer, okay? So it points to something, okay? When you say P1 is a pointer and you say and x1, just x, sorry. It says that this is called reference operators. So it gives you the address of the variables. So basically it says P1 should point to this. Okay, so pictorially, this is like a pointer like that. So this is a pointer, but in real life, you have a memory in your machine, and x is somewhere. You have an address like this, maybe address 1,000, and a also is somewhere in the memory as well. It may take space more than one slot, and you have this 10.5, and it also has an address associated with it. And finally, in somewhere in your memory, you have P1, and P1 keeps points to this position, so it basically keep the address of that position. So this is how it works. Okay, so P1 is somewhere, and P2 is somewhere, P3 is somewhere. Okay, like that. Okay. If you don't initialize it, you may have some garbage here. This is for P2, this is for P3, P1, P2, P3, this is for X, this is for A, like that. Okay. Now, when I say star P1, so you have P2 and P3. These are variables that are not initialized. Okay. So you may have some garbage here. Okay, when you say star P1 equal 50, this star is called, so it's the different thing from this, okay? So this star is basically is part of the type, meaning that it's a pointer to int. When you read the type, you read backward, okay? Like that, okay? Now, when you use a star as an operator to the a variable, this is called, so this one is reference, this is dereference. So basically, P point to something, star P means something that P points to. So basically, when you say P1 equals 50, you change this value to 50, okay? When I say X plus, so it should be, sorry, it should be X1, okay? When I say X1 plus plus, okay, so you increase the value of this to 51, okay? Now, if I add another line here, say Cout star P1, you would get 51, okay? Because P1 point to X1, and if you change the value of X1, the thing that P1 points to also change. Now, when I say P2 equals P1, this would mean you have a P2 here, point to somewhere stupid before that, and then you have P3 that point to somewhere stupid, okay? When I say P2 equals P1, so P2 points to the same thing. And in memory, in your memory, you have that P2 would be 1000 as well, like that. Now, when you say star P2 plus equals 20, so this increased to 71. And when I say P3 equals and A, so it's point to A like this, so it keeps 2000 here. Now when I say star P3 equals 5.7, so you change this to 5.7. Okay, this is kind of quick review on pointers. When you write, you need to practice on pointer tasks, sort of like you need to think about it like this, okay? You can also use pointer and arrays interchangeably, okay? This is a kind of syntax that you should try to get familiar with if you want to work with C or C++, okay? So let me try to give you some example here. I think you have seen it once or twice or many times, but let's see. Let's see it again now, okay? So okay, so you have an array X, okay? You define it to be X of size 10, right? So this is X, and this is X0, X1, X2, and so on. And the last one is going to be X9. This will be in the memory, okay? When I say star in P, so what exactly is P? P is a pointer, right? When I say P equals X, now this interesting part. When you when you refer to an array with just the name of the array, you get the pointer to the first element. So basically X here, you refer to X. When you refer to X, you have a pointer to this this location. So when you say P equals X, so basically P point to the first guy. Now, if I say star P equals 10, so you have a 10 here. If I say P plus 5 equals 20, so this means the next, so P is a pointer to an int. So this is, you have to be careful about this. This is called pointer arithmetics. If P is of type int, if you increase it by 5, it makes to the next 5 integer, okay? So when you say P plus 5, so it's going to be P, so this guy will be P plus 1, plus 2, plus 3, plus 4, plus 5. So you're going to go to X5 here, okay? When you say star P plus 5, so P plus 5 is points to this. So when you say star P plus 5 equals 20, so you have 20 here, okay? Now, if I say p plus plus. So you increase p by 1. So now p points to this location instead, to this. Now, when I say star p equals 30, so you get 30 here. P plus 5 now points to x6, okay? So when I say star p plus 5 equals 40, so you get 40 here, okay? If you increase p again by 3, so now p would point to where's p now? 1, 2, 3. P would point to this. Okay, and when I say p plus 1 equals 50, so you have this guy become 50. Okay, so if you try to get familiar with pointers and arrays, you see that they are interchangeable. Okay, but this example basically shows you how to do pointer arithmetics. It's really helpful if you want to iterate over an array using pointers, because you don't have to keep index. Okay, you don't have to keep indices of these arrays, and pointers are sometimes easier to think about, but sometimes it's messier. So yeah, we'll see. Okay, now so this is so in this example we use pointers to access arrays. Okay, now let's see some more example. Okay, so again, same thing here. You can also think of x. Okay, again, if you think about this line, okay, so you have an array, and when you say so this x0 and so on, x1 and so on, if you refer to an array with just x, basically it refers to the pointer to the first guy, right? So now you can use x as a pointer as well. So then this is like this. So when you say star x equals 10, so give 10 to here. You can say you can even say x plus 5 star. So you're gonna assign this to some x5. So 20 here. So same thing here. So you can think of it as a pointer and use it as a pointer, even though it's an array. Okay. And the fascinating thing about C is that you can use pointer as array as well. Okay, so star p is basically equals p0, right? So you can say so this is equivalent star p or p0 10, because if you write like this, basically so when you say x0, right, you think about it, if you think about x as a pointer, x0 is the first guy, right? So same thing here. If p point to something, you can access it with p0. This is like use pointers as array. Okay, and this part you use array as pointers. So they are kind of like interchangeable. Okay, so because of this this thing. Okay, but this can be confusing. Okay, the key difference between pointers and arrays is that here in the memory you have p, okay, which is a pointer to something. Here, when you define an array x, you have an array x, but x here is not a really perfect variables, because it has no it has no memory slot for it. Okay, you can have x that would give you the address of the first guy in the array, but x is not a pointer. You can use it as a pointer, but it's not a pointer. Okay, so you cannot do this. Okay, you can think of it this way, right? You can say this is the same thing. Okay, you have array X. Okay, and you have pointer P. Okay, you can use this interchangeably. Okay, you can, but with pointers, it has perfectly. It has a location, so you can say P point to X, and you can increase the value of P. Okay, if you increase the value of P, P moves. Okay, so basically when you say P plus plus, it points to this value, right? And then you can think of it as array again. But now your array, when you access array using P, you can shift it pretty easily by changing the pointer P. You can say P plus equals 2. So it move again to this location, right? And you can access it as an array as well, okay? But you cannot do this. You can not just say X plus plus, because X, when you access X, you get an address, right? But there's no, X is not a variable in the same sense as P, okay? X refer to the address of the first element in the array, but you cannot change it, okay? Because X is, there's no variable X, okay? There is an array X. If you access the array by its name, you get the address, okay? And that's it. There's no variable X. So you cannot do this, okay? If you like to explain this in more formal terms, there is a concept of L value and R value, okay? So L value is something that you can use on the left side of the equation of the assignment. So you have an assignment like this. Okay, so this part is R, this part is L. So R value, when you say A, X equals A, right? Okay, so you have two variables here, X and A, but you use it in two different meaning, okay? If you use the variable on the right hand side, you ask for the value of it. If you use the value on the left hand side, you refer to the location of the memory slot that you can change, right, in C. So using something on the right side, you get the value. If you use something on the left side, it means you would like to go to the memory, right? So storage, okay? Not the value of it, okay? It's not like you are assigning value to value, no. You look at the value and you assign it to the storage or the memory or the variable, okay? This is perfectly fine with P because P has value, okay? So you can say star P, you can say P5, you can just use it as a P because it has value, okay? So you can say P2 equals P or something like that. You can do that with X. You can say P equals X, right? You can even do some int y equals x10, right? You can use X on the right hand side because X is kind of like it has a value. It can provide a value, but you cannot change the value of X. So you cannot do this. You cannot use X on the left hand side, okay? So we say that P is a variable that you can use as R value and L value, okay? It has L value and R value, but X only have the R value. You cannot use it on the left hand side, okay? So when you think about array and pointers that can be used interchangeably in C and C++, they can pretty much be used interchangeably, right? Except this case, you can change the value of a pointer. I mean, you can point it to somewhere else, but if you have arrays and you access the array names, you get the pointers, right? But you cannot change it because the array has a fixed location inside the memory. Okay. Um, okay. It will become more apparent if you try to use this kind of thing with multi-dimensional arrays, but I'm not gonna go much into it. Okay. Okay. So something that you need to know before you use STL is to how we use pointers to iterate over arrays. Okay, so this is a simple code that compute the sum of numbers inside X. Okay, so when you work with competitive programming tasks, you usually have the limits on the size of the inputs, so you can pretty easily define an array like this. Even though when you get the input only contains 50 elements. So this is how I write it this way. I would like to find the summation. Okay, so this is a simple code to do that. Recall again, it will be really useful for you if when you define a new variable, you get it initialized. Okay, so I have sum 1 and sum 2. So I compute sum 1 this way. So I iterate over X using in an index I. Okay, so this is a typical code that you would see. Now you can do that using pointers. Okay, I can have a pointer P that in the beginning point to X. Okay, and when I want to sum it, I use star P. So this is how I get the value of P. So let's see it pictorially. So you have X here and many items, right? So X0 and it's end with somewhere X49. Okay. In the beginning, I say P equals X. So P point to this. When I say star P, you get the value of this guy. Okay. Now, if I'm not at the end, so this might look strange, okay, but this is, if you think of it this way, it will be helpful when you use STL later on. Okay, now if you are not at the end, so this, you can think of this as the beginning and this is the end. If you're not at the end, you increase the pointers. Okay, so P now move to this location. Okay, and then you add it to the sum, and then P move to this location, and so on and so on. Okay, and this will stop if P is at X90. P you're not gonna stop, right? Okay, but you're gonna stop when what? When here, when P is here. Okay, so if P is at the end, so the for loop works like this, right? So you do this, you do that, and then you increase, and you stop when you at the end of the array. So this is the last element. Okay, this is last element. Okay, if P point to the X plus N, so this is not the last element, right? The element after the last element. So if P is at the element after the last element, you stop. Okay, so this is like, yeah, keep doing that if you're not at the element after the last element. Okay, so here it has the same meaning, but writing this way will be easier when we work with STL libraries. Okay, so I hope you get some idea on array and how to iterate over an arrays. Now let's have a quick review on two-dimensional arrays. Okay, because there will be some tasks that you need to do today on using two-dimensional arrays. So basically, if you have two-dimensional array, this is how you define it. Okay, and you can use two indices to access an element in the array. Okay, now the crazy part, if you like to think about it, is that if you refer to X, so you have a two-dimensional arrays. You think it this way, right? It's of size 100 and 100. Okay. If you think about X, X is it's gonna be, oh, let's see, X 0, 0. This is this guy. Okay. You have X 0. It's a pointer to the first guy in the first subarray. So let's do it this way. So let's work on row base. So X0 is this array. X1 is going to be this array. Okay. So when you say refer to X0, it points to the first guy. When you say X1 is the pointer to this guy. But what exactly is X? X is also the pointer to this guy, but it's going to be int star int. Okay, so it's kind of crazy if you think about X this way, but you can use it like this. But again, you cannot change the value of X, so X doesn't have the L value. Okay. Okay, so now I think we can go ahead and see the STL now.